Hello people, welcome to Science Jump. Today we're going to be doing something a little bit different. I'm just going to be reviewing the Rustart Physics Optics Kit from Amazon. This cost 54.99 dirhams. That's about 15 US dollars or around 272 South African rand. Or if you're from South Korea, it's around 22,000 South Korean won. So what do we get? We got this thing. Battery's not included, but you have these laser light things. Obviously I'm in quite a well lit room, so it might be slightly tricky to see. And what's interesting is if you hold it like this downwards, you can actually use it as like parallel line. You can use it to straighten out like hangings on the wall and this type of thing. But anyway, like that, you've got these 3 lines which come out. Pretty cool. Mine seems to have a little bit of an issue down here, so this one, you know, you got a little bit of dispersion there, but then you got the lines, and the further you get away from the actual thing, the fainter it becomes. But it's all good, I quite like this. We have a protractor printed on a piece of paper. That's pretty useful. What's slightly less useful for me is on the other side we've got a diagram of the eye in Chinese. I don't read Chinese, but my Chinese audience, I'm sure they'll now learn a little bit about the structure of the eye. Right, what else do we have? We got this thing, probably quite tricky to see. Let me put it down there. Okay, so now what do we have? We've got, on one side, we've got a plane mirror, so that's completely flat. Okay, over here, we've got a rough surface. This side, we've got a convex mirror. And on this side, you've got a concave mirror. What else do we have? I'm assuming it says it's a pack of 8 different optics. Now, for $15, I'm not exactly expecting Carl's Zeiss quality. And yeah, it might be quite tricky to see because it's all transparent, but hopefully the effects of all of this will be kind of worth it. We'll have a look at this mirror thing first. Now, the idea here is if you put your mirror, the plane mirror, the flat one, right up against this line, your normal line is going to be all the way up over here. Then I can use the laser to have a look at the angle of incidence and the angle of reflection. I'm just going to use a central one over here, and I'm aiming for that point there. Okay, so I'm aiming for just here. That's where my mirror is going to be, and I need to hold it all down. And if I go in at a 20-degree angle, so 0 degrees is the normal line, so it's 90 degrees to the surface, but it reads as 0 if you're right up against the normal line. So down here, this is the angle of incidence. It's 20 degrees, and you can see it's right there, 20 degrees for the angle of reflection. So it's really good for that. If you have the parallel lines as well, you can see what happens with multiple things. And if you get closer, you know, it becomes a little bit brighter. So that's pretty cool, I like that. And of course, if you change the angle like that, the bigger this angle over here, the bigger that angle becomes over there. So that's the law of reflection sorted for this. So what about the other sides of the mirror? Let's have a look at the rough surface. Okay, now it's interesting, isn't it? Because this doesn't look like it reflects at all. Obviously it just scatters. You can see a little bit of red over here. So some of it's going over there. And you can see if I move it, you get some over there. So this is why you cannot see your reflection when you look at a wall, for example, because it's a rough surface and you end up with a diffuse reflection. It is incorrect to say that a wall or a table does not reflect any light at all, because if it didn't, we wouldn't be able to see it. It's just, it reflects it in all different directions. Kind of what's happening here. It's not following this thing like the plane mirror would. If we have a look at this one, so this is a convex mirror. Now you can see the light rays are being pushed away, they're diverging. So that's what the light rays are doing here, they are diverging. And if you have a look at the convex, you can see there's a crossover point. And if I move this, you can see the focal point is moving around. That's the focal point of this. Now, this kind of mirror, the concave mirror, because the light rays converge at a point over here, it forms a real image, whereas the other ones form virtual images. So that's this little mirror sorted out. What else do we have? We have these lenses, the rectangular one. Okay, now, if it's completely 90 degrees, the light beam is just going to pass all the way through. But if I come in at an angle, like so, you can see refraction happening. That's pretty cool, isn't it? So it's no longer in a straight line, it actually changes the direction a little bit. Okay, like that, you can see clearly that ray of light has changed direction. We got these lenses over here, and look at what this is doing. So you got a what's it called? Convex on both sides, and you've got a focal point all the way over here. Okay, if you're perfectly in line with the optical axis, it will like that. We've also got a double concave. Look at that. So now what's going on over here is the rays of light are diverging. You can even combine them. So you can even put one like this and one like this, and you got like different effects happening. And this is what like camera lens manufacturers do. Right, what else do we have? We've got a semicircle. So that does like this. Very interesting, very interesting. It's just good to play with, you know? We have one more like this, so I don't know what the difference is between this one and this one. I guess one is thinner, one is fatter, but let's see if it makes an actual difference. So this one, I'm gonna put something to mark out its focal length. I'm just going to put the tip of that mirror over here, okay? And what's going to happen when I have a slightly thinner one in its place instead? Have a look at that, the focal point moves around, and of course that makes sense because the thicker this is, the more it's going to converge the rays of light. You can even have two like this together. Yeah, just playing around with it. Got like this as well, okay? That's interesting and fascinating stuff. And we have a triangle. Now, what I'd quite like to have is a white light source, so that way I can use this prism thing to what's it called, split it out. But you can see with this red light, the light beam bounces off like that. That's so cool, isn't it? I think that's pretty cool. Okay, and there we are. That's the 55 dirham optics kit from Amazon. I think it's great, but I'm a bit of a nerd. Tell me what you think in the comments below. Like, share, subscribe. Thank you very much. Goodbye.